Hello students, so today we will discuss some of the numericals from this chapter. Okay, but before I start, I want to revise something that I gave you in your last class. The first one is what? Mass percentage. So for mass percentage, we took the example of 10% of glucose in water by mass. Okay, now here percentage, that means the total amount of mass in this solution is how much? 100 gram, and only 10% of glucose is there. That means the mass of glucose will be how much? 10 gram. Okay, and the mass of water will be how much? 100 minus 10, that means 90 gram. Okay, that means there is a 90% of water. Okay, and same for the volume percentage. Just change this unit from gram to ml, otherwise everything is same. Our next one is what? Molar mass. So you already got about the molar mass in your first year. Okay, so how to calculate the molar mass? So let us take the example of water. Okay, so here the number of hydrogen is 2 into atomic mass of hydrogen plus number of oxygen into atomic mass of oxygen for water molecule. Okay, and we know that the atomic mass of hydrogen is 1 plus 1 into atomic mass of this is 16, so this will be 18 gram per mole. Okay, so we calculate the molar mass in this way. And then the next one is number of moles. Okay, next one is number of moles of any compound or any molecule. Suppose you have given 10 gram of carbon dioxide. Okay, now you have to calculate the number of moles for carbon dioxide. So number of moles is denoted as NCO2, and the formula is given mass by molar mass. Okay, and the given mass is how much? 10. And the molar mass for carbon will be how much? 1 into 12 plus 2 into 16. So this will be divided by 12 plus 32, 10 by 44. This will be 0.2 something mole. Okay, so these concepts are very important because we need this concept to solve our numericals. So your first question is calculate the mass percentage of benzene C6H6 and carbon tetrachloride CCl4 if 22 gram of benzene is dissolved in 22 gram of carbon tetrachloride. So here given your mass of C6H6, that means benzene is how much? 22 gram, and mass of CCl4, that means your carbon tetrachloride is 122 gram. Then the mass of the solution will be how much? 22 gram plus 122 gram. Yes or no? That means addition of these two masses. So this will be 144 gram. Okay, that means the mass of the solution is how much? 144 gram. Now you have to calculate the mass percentage of benzene and carbon tetrachloride. So we know that the formula of a mass percent of component is equal to mass of the component in solution divided by total mass of the solution into 100. Now first of all we have to calculate the mass percent for benzene, that means C6H6. So the mass of the component in given solution is 22 gram divided by total mass is 144 gram into 100, and this will be your 15.28%. okay, and mass percent for this CCl4, that means carbon tetrachloride, the given mass of the solution is how much? 122 gram, and the total mass of the solution is 144 gram into 100, and this will be your 84.72%. Okay, so your next question is calculate the mole fraction of benzene in solution containing 30% by mass in carbon tetrachloride, that means CCl4. So solution will be here given 30% of benzene in CCl4 by mass. Okay, that means mass of C6H6 will be how much? 30 gram, and mass of CCl4 will be 100 minus 30, that means 70 gram. Okay, now we have to calculate what? Mole fraction of C6H6, that means benzene, and the formula is C6H6 and C6H6 plus NCCl4 for benzene. Now here NC6H6 means what? Number of moles of benzene, and NCCl4 means what? Number of moles of carbon tetrachloride. So now we have to calculate first NC6H6, that means number of moles of benzene, and the formula is what? Given mass by molar mass, and the given mass for benzene is 30 divided by molar mass will be what? 6 carbon into 12 plus 6 hydrogen into 1. So this will be 78 equal to 0.385. Okay, and for NCCl4, this will be given mass is how much? 70 divided by molar mass will be for 1 carbon 12 plus 4 into, and the atomic mass of chlorine is 35.5. So this is 70 divided by 154, and this will be 0.455. Now just put the values of this in above equation. So, and mole fraction is also denoted by this symbol. Okay, so mole fraction for C6H6 will be, the value of NC6H6 is how much? 0.385 divided by 0.385 plus 0.455, and this will be how much? 0.458. You can give also the unit mole. Ultimately this mole will be cancelled out, and so the next question is calculate the molarity of each of the following solution. The first one is 30 gram of cobalt nitrate 6 water in 4.2 liter of solution. Okay, so here the mass of solute, that means CONO3 whole 2 6 water is given how much? 30 gram. Yes, and volume of the solution is given 4.2. I have to calculate now molarity of CONO3 whole 2 6 water. Okay, and the formula is what? Mole of solute divided by volume of solution in liter. We know this formula. Okay, now mole of solute, that means number of mole of this CONO3 whole 2 6 water, and we know the formula is given mass. The given mass is how much? 30 gram divided by molar mass, and the molar mass for this solution will be, the atomic mass of cobalt is 59. Just remember these values. Okay, and how many nitrogens are there? 2 nitrogen, and the atomic mass of nitrogen is 14, plus how many oxygens are there? 3 into 2 6, and atomic mass of oxygen is 10, plus how many waters are there? 6 water, and we know that the molar mass of water is 18. Okay, so now 30 divided by, after addition you will get the value how much? 291, and the value will become 0.10. Okay, now calculate the molarity. molarity will be mole of the solute, how much, 0.10 divided by volume. Now just put the values of number of moles and volume of the solution in the formula of molarity. Okay, so mole of the solute is 0.10 and volume is given 4.2. okay, so after calculation you will get 0.02 molar. So the next one is 30 ml of 0.5 molar sulfuric acid diluted to 500 ml. okay, so we have to calculate the molarity of a diluted H2SO4. so here first of all the volume of undiluted H2SO4 is given how much, 30 ml. okay, so take it as a V1 equal to 30 ml. okay, and 0.5 molar, that means this is the molarity of a undiluted H2SO4. consider this as a M1 is equal to how much, 0.5 molar, and the volume of diluted sulfuric acid is given, volume of diluted H2SO4 is given how much, take this as a V2, this is 500 ml. Now you have to calculate the molarity of diluted H2SO4, that means M2, and the molarity of a diluted solution is calculated as M1V1 is equal to M2V2. so this will be M2 equal to M1V1 by 30 into 0.5 divided by 500. so this will be how much, 0.03 molar.